Hey everyone, my name is Armando,
I'm Lizzie.
and today in this video we're going to be covering an important concept to object-oriented programming, and its methods. Tell me, what is a method?
Well, glad you asked. So a method is just like a function, except it's associated with one specific class, and it's declared within that class.
So the basic format or syntax for a method is just the name, the list of its parameters right here, and then a single return type. And then inside here, we have the actual body of the method where it does like all the manipulation of the different properties or whatever work you want it to do for the class.
It may look pretty familiar to you. It looks just like a normal function, which is pretty helpful.
So for example, here we have a class we're going to call dog. So it represents like a dog object. So here we have the three properties: is fluffy, which is going to be a boolean, the name, which is a string, and the number of treats consumed, which is going to be a number. And so you can think of these properties as specific to to any instance of a dog object. So for every dog object that we have, there might be variations in each of these.
And so below it we have our first example of a method. So sort of like we were saying before, it looks just like a normal function. We have our name, our return type, or in this case we don't take any parameters. And then all this function does is change the is fluffy property to false using this very special this keyword. The this keyword just refers to whatever specific instance of the object the method is called on. So in this case, whatever dog this is fluffy property would be changed to false, and then we would return the new is fluffy property, which in this case would also be false. Great, so now we're actually going to create a dog object. So say we want to create this dog arf. We're going to say let arf be of type dog, and then say it's going to be a new dog. And what this new keyword does is just create a new dog object on the heap, which this variable arf will then point to. And the new keyword is just really important whenever we're creating a new instance of an object.
Okay, so now let's say we just want to give our dog Arf a haircut. So what we do then is just say arf dot haircut. So this is going to actually call the method within arf. So here we're going to go in here, and then every time we see this is actually going to refer to the object instance that called it. So in this case, we can just cross this out basically and just call this arf. And it's just the same thing right here. So then what we're going to do is then change the is fluffy property of arf to false, and then end up returning arf.isFluffy, which would be false.
Okay, and say because arf is no longer fluffy, we don't like him anymore, so we want to get a new dog. So we're going to create a new dog called bark, and we're going to, again, using this new keyword, and you've just taken out the type, we've just let it using type inference. So we've now created this new dog called bark, and these two, arf and bark, will be independent of one another. So even though we called haircut on arf and changed its is fluffy property to false, bark's is fluffy property will still be true, because when we create this new dog, we're creating a new dog with all of these properties.
So now we're going to have a new method in our dog class. This one was going to be called treatYoDog, and it has a parameter this time, which is going to be called tease, and it's just a number. And the return type of this one is just going to be void, since we're not really going to return anything from this one. And basically what this method does is just changes the treats consumed property of the current object we're working on, and increases it by the number of teas we give it, or treats.
So for example, bark has been very good, and we want to give him 4 treats. So we would call this treatYoDog method on bark, which would then, with our 4, which would become our teas. So then we would say, again, like before, we can just pretend that this is being replaced by bark. So we would say bark's treats consumed property is increasing by 4. So now our treats consumed property for bark would be